I explain a bit on primary air pollutant. Primary air pollutant is actually generated from the source. So for secondary air pollutant, there's only one in our PSI, it's ozone. Ozone is a secondary pollutant because there's a reaction that resulted in ozone, which I'll explain later in every pollutant explanation. So PSI are measured, and the highest sub-index of each, comparing the six, is taken as a PSI for the day. Okay, PSI are measured 24 hours and 3 hours, and PSI are reported hourly now. So it's a running average every hour that we reported. 24 hours, keep on moving, the average. And first, I will talk about particulate matters. That means including PM10 and PM2.5. Okay, PM is actually the finely divided solid or liquid, which remains suspended in air over hours or days. So for those PM that's very light and very fine, we can fly from Indonesia to us. Yeah. Okay. Secondly, they are actually classified by size, density, shape. So commonly we just name it as particle size, by their big or small. So I also need to tell you where are the source coming from. For the bigger one, it's coming from our road, construction, industry emission, and fly ash from burning oil and coal. Okay, when you burn oil and coal, right, you actually have a byproduct of fly ash. Yeah, now they are recycling the fly ash as well to cement mixing. So for the even finer, it's actually from burning on fossil fuel. And vegetation, that means forest fire. So this picture is actually show you the size of our PM10. PM10 is blue in color. This is a hair. Our hair, one of our hair. One strip of our hair. So this is PM10, and PM2.5 is this small. So at least 5 equals to 1 PM10.
Actually, why do we have to learn about all this kind of thing? You just tell us how to calculate this, I can really know.
Of course, you need to know where the source comes from. As a PCD officer, you need to know the source, and you need to reduce it. So this is called reduce at source. Right?
Nigel, is burning of the Chinese money, considered part of this? I mean, does it also affect the PSI?
During the 7 month.
Sometimes not even the 7 months. Sometimes they just burn.
Okay, as a Chinese, right, we have certain date that we need to, for religious purpose, we need to burn.
Yeah.
So that contribution is not as much as forest fire.
But sometimes it can be really bad, So how do you know how bad is the contribution if you're not in that scene?
Okay, we actually can monitor by day. If that day is a special day, right, we can monitor the trend, compare with other day. So if there's a spike, we can possibly say that it's come from burning the sandpaper.
So if I experience, let's say I'm staying on the, let's say I'm experiencing this, a lot of smoke and fumes around where I stay, and it's affecting me. Can I call NEA?
Yeah, there's a NEA hotline, or you can use the NEA apps. Depend on situation. If your case is minor to us, to our officer, to you also, we will maybe handle it the next day. Or there's multiple source of feedbacks. Maybe in the same area, you stay Sengkang, and there's 10 complaints coming at the same time. That means there may be a particular source at the area burning, or there's a forest fire.
How would you really regard a minor issue? I mean, what is minor to you? Does it mean that you need a mass number of people to complain in order to take action?
Not take action, it's immediate or a day later.
A day later,
At night.
the result.
It's at night, or I mean during the night.
But wouldn't the result be different? Wouldn't it affect?
So if this problem continues, we will also take it as a serious case. So minor, you build up to a major issue for us.
Shouldn't a minor problem be caught first before a major problem?
but we can't handle so many minor problems. Of course, we must solve the major issue, then as a result, it will reduce the minor issue.
But then damage is already done, right?
No, if damage is already done, it's major issue.
So if there's damage done to an individual person's health, how?
So for example, she's asthmatic,
Yeah.
and then there's, for example, during 7 months,
Yeah.
there's a lot of burning around her.
So she should take precaution. If she knows they are burning.
So basically, NEA won't step in straight away.
Okay?
Not convincing.
Not convincing. So maybe I'll explain the health now. How the particular size affect human health. Okay, for bigger PM, right? Mostly, explain your problem. Mostly check in the nose, throat, and subsequently clear. When you cough, actually clear. Later I'll show you an animation. How this PM 10 and PM 2.5, what is the difference? And for fine particles smaller than 2.5, it can actually enter your airway, your alveolar, or your bronchitis, and it poses greater health risk. So now I'll show you the animation which I cut from YouTube. So there is no sound, maybe you can read.
It's extended mode. You have to push it left or right. Yeah. 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 Wait. So this is PM 10 entering your throat. So we actually start here for the bigger particles, and you can just cough it out. And for the smaller particles, you actually enter your bronchitis and your alveoli. This is your alveoli, where the air exchanges take place here for your blood. So your blood actually take in oxygen to help to spread to your organ, because your organ needs a red blood cell. And this is our defense. So we actually attack our defense. There's a fight going on in your body. When we have a long chronic exposure, and they are outnumbered because long term.
Iron Man.
Because they are in China, they are mostly high. Their cold weapon is actually high ash, high mercury. Yeah, so this is our defense, but they will overwork because it's chronic exposure. And they have even smaller PM, like PM 0.5, can easily enter your bloodstream. And once they enter, you narrow your blood vessel. See? In the end, you will go to your heart and causing irregular heartbeat, and heart attack occurs. Stop. Okay. So I'll move on to the third pollutant in the PSI, SO2. SO2 is primary pollutant, colorless, but there is smell. When I say about smell, you produce a sour smell. You want to drink some water? Yeah, keep yourself awake. Yeah. So the source is coming from either you're burning coal or fuel oil with high sulfur content. And for Singapore, more than 90% of our SO2 is coming from a refinery. For Singapore, there are 3 refineries: SRC, ExxonMobil, and Shell. So SO2 is very for acidity in your air, water, and soil. They will react with water to create acid rain, and it will damage our building, our forest, even our water, causing our water become acidic. Move on to the fourth pollutant, NOx. nitrogen oxide. Nitrogen oxide primary pollutant mainly NO and NO2. In PSI measurement, we just measure the NO2 instead of two of them. So they are actually in our air. Okay, nitrogen in our air is 79% for information. So whenever there is a burning take place, right, you actually react with oxygen and become NO2 or NO. So this is NOx. And NOx is responsible for acid rain. It's different from SO2. SO2 is forming a sulfuric acid, and for NOx is actually becoming nitric acid. And NOx is also can cause smoke, which is in the presence of VOC and sunlight, it will become ozone. Smoke is a subset of ozone is subset of smoke. So this is the fifth pollutant, carbon monoxide. Carbon monoxide is extremely dangerous. It's a primary pollutant, colorless, and odorless. The most dangerous part is odorless. You can't detect by your nose. And it may cause death to you if you don't know the gas is present. And the source is from incomplete combustion. Can you give me an example of
incomplete combustion?
No, the previous pollutant. What is the previous pollutant?
Is it sulfur? NOx.
Yeah. Can you give an example of the source for NOx?
Is it from the refinery?
Nope. Okay, NOx is, I repeat, NOx is present, okay, nitrogen is present in the air, 79%, oxygen is 21%.
Okay.
So when you do any combustion, there will be NO and NO2 produced. That is NOx. Okay. I'll come back to CO now. So CO is incomplete combustion. Any burning that is incomplete will produce CO. For example, your car, when you cold start it from a normal room temperature, you cold start it. At the start, it will produce very high CO. And also, of course, forest fire. So the toxicity is CO will actually fight O2, which bind to your hemoglobin. Hemoglobin is your red blood cell. So when the CO replaces your O2, that hemoglobin cannot bring the red blood, the O2 to your tissue, which causes organ failure. Yeah. And it also causes headache and unconsciousness, followed by death. So the next pollutant is on ozone. Ozone, as everybody knows, ozone layer, yeah, it's very good, very good. But that is in the sky. It's the stratosphere, is above the ground level. Ground level is stratosphere. So ground level ozone is actually dead ozone. So that ozone is a formation from NOx and VOC, same. When they react under the sunlight, they actually form ozone, and usually it's from our vehicles source. And the toxicity is irritation to your mucous membrane and effect on your lung. And it can enhance the smoke. This example you can search in the internet on LA, which have this problem because the surrounding is a mountain and it's blocked by the dispersion. So there's poor dispersion. As a result, there's a build-up of NOx, VOC, and sunlight, causing them to have pollution issue. But they have solved the issue now, thanks to their control in their car engine, Euro standard. So this is the learning outcome. For the first one, you have achieved. So well done. And I'll move on to the computation of the PSI. So this is the PSI which you have on the table. So you want to join the group?
Yeah.
So on this part, there will be a games on it. So I need you to understand the breakpoint first. So everyone has a breakpoint. So the step one of this PSI breakpoint is to identify the target pollutant. For this example, I pick SO2. So follow the red box. Step 2, I identify the concentration. Assuming SO2 is 100, so I pick to this moderate box. Step 3, I identify the sub-index. Still the same scenario. Assume 24-hour SO2 is 100. Step 4, identify the index category. So it's moderate. So now there's a game. As you can see from the board, there will be group 1 and this will be group 2. So and you need to draw from this box. Assume. Step 1. Now draw one of the pollutant. This is step 1. Okay, draw. Okay, draw. And draw one step 2. So you can draw step 1. One of the step 1. One of the step 2. One step 2.
Sorry.
Okay? One of the step 2. Okay, now you need to come up with what is PSI sub-index and the index category. This right on the flip chart. The answer. Masters have prizes. Okay? The correct answer on the board.
Pollutant.
What is your concentration?
10.
Your sub-index got this one.
Index category
Zero
unhealthy.
to-
Unhealthy.
0 to 80.
What is your pollutant? What is your concentration?
Concentration is that. Wait, no.
You just now.
That's right.
Okay, this is step 3.
Step 3 is 201.
Yeah, sub-index.
201.
Yeah, correct. Very healthy. It's very unhealthy. Yeah. Okay. Okay, so from the quiz of the game, the winner is Leonard Reed. Congratulations.
The price.
You won the mineral water, 3 bottles. So there is a bonus question. For individual. So it's a bonus game. Please raise your hand. Only the fastest will win the prize. Assuming the PSI sub-index and category from the previous game are the same and it occurs on the same day. So which is the reporting pollutant for the day? It says PM what? What's that? PM what?
PM 10.
PM 10.
PM 10.
Okay. Congratulations, you have won another bottle of mineral water. Okay, so the learning outcome, the second learning outcome you have achieved, how email compute the PSI. So well done. So now is the review of learning. That's the question. What have you learned? So these are the questions. What are the 6 pollutants in the combination of PSI? Maybe Michi, you know the answer?
What are the 6 pollutants?
Yeah.
PM10,
PM 2.5.
SO2, NO2, CO, O3.
O3.
O3, O2, NO2, yeah.
No, please not.
SO2,
O2 no.
You give us a chance, you also want to answer.
CO2.
You answer second question.
You another bottle?
You already got your water.
Yeah. So how many are there? How many? List one by one.
PM10,
PM10,
PM2.5,
PM2.5,
SO2,
SO2,
CO3,
NO2,
CO3,
CO3,
No,
what is
O3,
CO3?
CO3, NO2.
NO2. Okay, correct?
Yay!
So group 2 will answer the second question.
PM 2.5.
Okay, correct? So the third question, I think I'll pick the smartest student, smartest learner in this class.
Oh my goodness.
Yeah, we say, can you answer this? There's 4 steps.
4 steps.
Yeah.
First, identify which are the pollutants.
Pollutants, correct?
Then you identify the concentration.
Correct?
And then you identify the sub-index.
Correct?
And then you identify the category.
Category. Alright, that's correct.
Alright.
Top learner in this class. So now I'll move on to the transfer or learning. You may ask how to apply by having this information, this animation show. What am I supposed to do with all this information? Alright? So I will share with you how I apply this information. So with this information, right, we will know what are the industry causing this problem. For example, if the haze is coming and the industry is emitting, we will not find the industry problem. But the public may say, hey, hello, NEA, the emission why from the plant so much causing haze. In this case, we must explain to them, it's not coming from the industry, but it's a transboundary haze that's causing this problem. Yeah. So you need to learn how to integrate the work from different units.
So what you're saying is that for different industry there could be different pollutant categories. Let's say if it's for the refinery, if they're creating a pollutant, then it would be a very specific one.
So their main pollutant causing harm to the environment is SO2. Yeah. So you need able to integrate like for example, you are working in Imam. Suddenly there is a high SO2 detected.
So I look at the industry.
So of course you must focus at refinery whether they are emitting higher SO2 than it. If not, you need to investigate whether there's any illegal burning in that area. You must know where is the station located. Okay? So know how to apply. So challenges faced in the application. So any idea? With all this information,
I have a question.
okay.
So let's say there are multiple pollutants. So what will be the PSI for the highest one?
Multiple? Of course, it's the highest score. Highest score.
Okay.
Okay? So the challenges faced, maybe perhaps one of the issue is maybe our staff to understand how to compute the PSI and how the PSI, which is top, which is second. Maybe both category are at a good, or both category are at very unhealthy situation. So pick which one.